Hello, my name is John Kariuki, and in this video, I will be doing a demo of the SPDK top application, which is the newest shiny tool that was added to our SPDK toolbox in the 20.04 release. The application was developed by Maciek, who's part of our SPDK team in Poland. And basically, the application is designed to resemble the standard top in Linux in that it provides the user with insights into how an SPDK application is using the CPU resources that are assigned to it. The application also allows the user to filter out columns that don't have any interesting data and also sort the data however they want. In case you're wondering, why in the world do we need another tool? Let's talk about that. So one of the common questions that's brought up when people adopt SPDK is they will run the standard top command and they'll look at the CPU utilization and it will hit them that the application is actually using 100% of the CPU resources that they've allocated to the application. And they will start asking questions like, does that mean that my application, my SPDK application needs more CPU resources? And oh, by the way, what is the SPDK application actually doing with these CPU resources? SPDK uses a POMO design, and what that means is when you launch an SPDK application and you assign it a couple of CPU cores to use, the SPDK application will launch a reactor on each of the CPU cores that you've assigned it. And it's that reactor that is in charge of scheduling SPDK work items such as polars and the SPDK lightweight threads to run on those CPU cores. So when you run the standard top command on your Linux system, you're going to see a reactor process, and that reactor process will be using all the CPU cores you've assigned to it. So let's go to my dev box and now demonstrate exactly what I mean. So on my dev box, I launched an NVMF target application, and when I launched the application, I assigned it 4 CPU cores to use. If I run the standard Linux top command, you can see that the application has this reactor that is consuming 400% of the CPU resources that I have on this box. So pretty much the reactor is consuming all the 4 CPU cores that I assigned to the application. So next, I'm going to run the SPDK top application and let's see what the output looks like. If you want to do this at home, you can find the application in the build bin folder in your SPDK repo. And when we run it, here's what the output looks like. There are 3 tabs, a tab for the threads, a tab for the polars, and a tab for the CPU cores. So we're going to start by looking at the CPU cores tab. And when we look at the information that's displayed, you can already see here that you're already getting a little bit more information about what the CPU cores are doing. So for instance, if I look at CPU core number 4, I can see that it's running 2 threads and 3 polars. And the other CPU cores, 5, 6, and 7 are running 2 threads and 1 polar. There's also information here showing how busy or how idle each of those CPU cores is. On the polars tab, there's information on the different polars that the application is running. So you can see in the polars tab that we have an NVMF uh, poll group polar that's running on each of the CPU cores assigned to the application. And then there's an acceptor polar to accept incoming NVMF connections, and that's running on CPU core 4. And there's also a polar for the RPCs. The next tab we're going to look at is the Threads tab. And this tab is actually displayed as the #1 tab for a reason. As you can see, it's got pretty detailed information into what the SPDK application is really doing. So there's a line item for each of the threads um, in the SPDK application. And for each thread, we can see what CPU core the thread is running on. We can see the different polars that the thread is running. And the polars are grouped into active polars, timed polars, and paused polars. And then finally, there is information showing how busy or how idle the thread is. As you can see right now, all the threads are pretty idle because I have not kicked off an IO workload. I'm going to use a different tab to run a script that will finish configuring my NVMe over Fabrics target and kick off an IO workload on the host side. As I'm doing that, you guys will probably notice some changes on this screen as new polars are being added to the NVMe target application. So I have finished configuring my NVMe over Fabric's target application, and as you can see, we have a lot more polars. So let me explain what I did, and we'll try and map that to the polars that we're seeing here. So I added 4 NVMe BDEVs to the target, and as I was doing that, you guys saw that we saw a polar being added for each of the NVMe BDEVs admin queue. And then the next thing I did is I carved out 2 LVOLs on top of each of the first 3 NVMe BDEVs. And then on the host side, I connected to all 6 LVOLs, but I'm only running the IO workload against the first 4 LVOLs. And that's why you can see I have 4 LVOLs that are pretty busy. Well, in case you're wondering, how busy are these reactor threads? Are they taking away CPU cycles that could be used to do rework? Well, we're going to look at the threads tab, and you can see most of the busy cycles are being used by the NVMF polar threads that are doing actual work. The reactors themselves are barely using any CPU. Most of the time, they're idle. You can filter out any columns that aren't showing you anything interesting. So in order to do that, you hit the C key on your keyboard, and then you deselect the column that you want to filter out, and then close the menu. And once you do that, the column will no longer be shown on the display. You can also sort the information that's displayed based on one of the fields here that's more interesting to you. So for example, if you want the busiest thread to float up to the top, you can sort using the busy field. To do that, you just hit the S key on your keyboard. You select the busy column in the sub menu that pops up, and you hit the enter key, and the information is sorted based on the busy column. Thank you so much for attending the SPDK, PMDK, and Intel VTune virtual forum. The next talk will be starting in a moment.